So today, Ana Paula will be presenting this paper about Brazilian research, which is pretty cool. And so, yeah, the floor is yours, Ana.
Okay. Thank you for the introduction, and good evening to everyone. I'm glad that we are more than we expected. So I'll be talking about selective reporting today. That is one of the practices leading to reproducibility issues. We know very well how common it is to have experiments that fail for easily identified or even for more complex reasons. And then we know that we have to repeat them a few times until everything goes well. And then until we have an appropriate sample size. So instead of writing about all the attempts and issues, we often report only the experiments that we judge to be correctly performed. Otherwise, the research articles would become huge and even unreadable. However, a careless decision of which data to disclose or omit opens the way for the selective reporting bias. So, okay, what would be this reporting bias? It is about not disclosing certain elements of a study, or even not disclosing the whole study deliberately based on the direction of the results. This way, negative or undesired findings are suppressed. Selective reporting bias can happen at different levels. First, it can be associated to the omission of specific outcomes or individual experiments. For instance, when several variables are measured, but only the ones that provide significant data are shown, or when an experiment doesn't provide the expected results, or it seems in contradiction with other data, then those things are left out of the story. It can be even the omission of whole studies, that is the publication bias, also known as the file drawer effect. And at the level of analysis, we could also cite the exclusion of outliers without using criteria that were previously defined. So when you look at your data and say that there's a certain data point that has a value that is too high or too low for a given measure, and then you decide to remove it without previously defining if it would be too low or too high. And it's not very easy to spot if the selective reporting has happened for clinical. It's not very easy to know if it has happened when we are reading a study. But for clinical trials, for instance, you can find if there was a pre-registered study before that resulted in no publication. In other papers, you can also be attentive to mismatched sample sizes, but it's quite difficult to know if there was an experiment that has been done and that has not been unreported because there is no trace of it. Why would be this reporting bias so common? At some level, it can be attributed to the experimenter having too much freedom to decide whether to include data or not. I think we can relate that to our day by day in the lab. Sometimes we get results that don't match our expectations, and then we start to find that reason, that other reason why the experiment wouldn't have worked, let's say. So you question if you apply the right volume or the right dose of a substance, or maybe you suddenly remember the animals looked more stressed than usual, and then you say, oh, we must be wrong because of this or that. There is also the issue of repeating the experiment again and again, or even modifying the statistical analysis until you find the desired results, and then you discard the other possibilities. Another issue is related to hacking, in which the hypotheses are done after the results. So you see the results and you make the hypothesis fill the data, and not the opposite. It should be the case. Just to give you an idea of the huge impact of bias reporting, how it can affect the distortion of information, I brought here the figure from an analysis that was based on clinical trials that compared the effect of antidepressants versus a placebo. And out of 105 studies of clinical trials, half of them were considered positive by the FDA, meaning that the antidepressant had a better effect compared to the placebo, and half were considered negative. Out of them, all but one of the positive trials were published, so here in green. Whereas from the negative trials, it was how much? It was like 30% of them were published. No, yeah. So in the end, from half positive and half negative results, we end up with positive trials representing about 70% of the published studies, and then the negative outcomes are underrepresented. Now, there is more to add to that. Out of the trials considered negative by the FDA, 40% of them were published. Here you see they become green, so they were published as positive, either by omitting unfavorable outcomes or highlighting outcomes that were only secondary. Furthermore, among the few remaining negative trials, we see that about 2/3 of them were published with some degree of spin, meaning that there was a bias reporting to induce the reader to conclude that the treatment was beneficial or to distract the reader from statistically non-significant results. Therefore, if you see, only 5% of all the published trials clearly reported that the treatment was not more effective than the placebo on that trial. On top of that, we can add another kind of bias, that is the citation bias, meaning positive trials were cited three times more than negative ones. So in the end, if you are looking for evidence that a treatment is effective, you can definitely find it in the published literature. What you don't see is the other side of the story. All the studies that found the opposite, and we don't have information about it. Considering that omitting data or even full studies might lead to the idea that an effect that is not so consistent is indeed true, would it mean that we should tell absolutely everything that has been done? This is one of the possibilities raised by the paper in question, but it's in a more refined way. It's not just simply as simple as this. We will discuss this later. Because just reporting all the experiments and the results, it could leave to the reader the responsibility to judge the quality and the strength of the results, which can be good. But on the other hand, it would be too much information. So it's definitely different from the concise papers you're used to reading. Also, there would be a risk of increasing the noise, so having too much information without giving importance to the main results, without giving a proper value to them. So there's likely to be a middle ground between telling everything and falling into this selective reporting trap. The authors of the paper I'm basing the discussion in, they propose 3 ways of avoiding bias. So all of them comprise defining the inclusion and the exclusion criteria independently on the obtained results. So the solution could be either full data reporting, pre-registration of hypotheses and methods, as well as blind data analysis. So let's see each of them individually. For the full data reporting, it was a bit mentioned here already, but instead of just providing everything without interpretations, there are more refined ways to show all the data and all the possibilities. An idea would be the multiverse analysis that consists of reporting the outcomes of several different statistical analyses. So this way it offers an idea of how much the conclusions change because of the arbitrary choices we make during the data processing and analysis. It also shows us how fragile or robust the findings are. There is an example that I would like to show you quickly. There was this study in which Stegen and colleagues, they analyzed data sets from two different studies by the same authors, assessing the effect of fertility on religiosity. And both of those studies, study 1 and 2, they found a relationship between fertility and religion. However, in the Stegen paper, they transformed those two simple data sets of each study, study 1 and 2, into many data sets to do a multiverse analysis. So they took into account the different possibilities of classifying the data that was collected according to categories of fertility, the status of the women of their relationship, the stage of menstrual cycle, and also different exclusion criteria. Then they created a multiverse of datasets by considering all the combinations of those criteria and how they would be combined for data processing. Then they analyze each data set in this data multiverse separately. And in the first two graphs, we see the distribution of the p-values for the multiverse of data sets of each study. So here they had 120 different data sets of different combinations, and in study 2, more than 200 data sets. And we clearly see that we have more significant analysis, more significant P's in the data sets of study 2, whereas the distribution in the study 1 is quite spread. So in the third image, I just want to show a tabulation of the multiverse and the individual p-values for each of the single combinations they did. It doesn't matter, it's not a matter of understanding what are those variables, but it's the fertility, religion, the menstrual cycle, and the exclusion criteria. I just wanted to give this as an example that depending on the way, on what you choose, the choices you made to categorize your data and to process your data, you can have a big range of different conclusions. The second proposal of the authors to avoid the selective reporting would be pre-registration. In pre-registration, there is the definition of hypotheses, methods, and the analysis plan before the study is conducted. This allows later tracking of what was published or not, like in the example I gave you with the antidepressant trials. For sure, for now, this is more common in clinical trials, in contrast to most of our research than in our kind of lab, where there are many exploratory projects, and then we decide which protocols to use. We keep developing new hypotheses as the research advances, but still it could be a good solution to have everything set in advance. Following this line, but then adding some new elements, there are some researchers that proposed that the exploratory studies, when they involve animal research of disease therapies, they should be followed by a large, independent, confirmatory study, in which all parameters will be set in advance, like the hypothesis, all the protocols, the steps. There would also be a very rigorous design and analysis, more than in exploratory ones, including blinding and randomization. And they propose a higher threshold of statistical significance. Of course, it depends on the kind of experiment. And this kind of study would be performed by an independent lab or even by a consortium. I'm being very brief about this, but I think it's worth discussing about the implication of this model after the presentation. So we can go back to this later. And finally, the third proposal of this paper is performing blind data analysis. So the exclusion criteria would be set independently of the results, and the choice of inclusion or exclusion would be made by blinded experts. This is quite easy to implement in our routine, but the authors claim that it is less optimal than pre-registration. But I think it's still quite a fair alternative. So after exposing all of this, That's it from my side. But to help guide our discussion, I'm bringing some questions that might be worth addressing. Like, do you recognize practices in the lab to prevent reporting bias? Do you see an interest in implementing any of those three suggestions in the routine? How feasible would they be? And maybe also the question of, do you recognize having already been biased, use this kind of selective reporting, even if you were unaware of this problem?